Welcome. We're going to do 153 and 154. Here we go. We got ourselves a probabilities problem, and we need to think about what this game is all about. So it says we play a game, and we say the value we get at the game is X number of points scored in the game. Then they want us to figure out what would be true for the sampling distribution of the sum, Y, when we play 2 games, or twice. Okay? So let me see if I can come up with an example of what this might be. So one example I think that may make sense is that this is a game. And in the game, so since it looks like the probability of this is 0.3, 0.4, and 0.3, right? I'm going to think of these as actual blocks, right? So it looks like I have 10 blocks. So I'm going to call this a 10-sided dice. So let's say I'm playing a game with dice, and it has a 10-sided dice. So it looks like if I add these up, I get 10. So it looks like 3 of the sides have the number 0 on it. So 3 of the sides have the number 0 on it. 4 of the sides have the number 1 on it. And 3 of the sides have the number 2 on it. So this would produce this probability outcome. So 3 of the sides have a 0, so we would expect to get a 0 30% of the time. And 4 of the sides have a 1 on it, so we'd expect to get a 1 40% of the time, or 0.4. And 3 of the sides have a 2 on it, because we'd expect to roll a 2 30% of the time. All right. Now that we kind of have an idea of how this game is played, what would happen if we played it twice and then we added our outcome? So anytime you roll a dice and you need to roll it twice, it makes sense to create kind of a T-chart here. So this would be my first roll. So the possibility of rolls, I'm either going to roll a 0, a 1, or a 2. Those are my only possible outcomes on my first roll. And then on my second roll, you guessed it, I'm either going to roll a 0, a 1, or a 2. So Y is the sum. So I'm going to use my table to calculate my sum. And again, that sum is equal to Y. So using this as an example, if I rolled a 0 the first game and then a 0 the second, my sum is 0. If I roll a 0 the first and a 1 a second, my sum is 1. So hopefully you get the point. 1 plus 0, 1 plus 1, 1 plus 2. Okay, so my possible outcomes for Y, have to span from 0 to 4. And so A, B, and C are definitely out of the contest here. Now I have to see whether or not this would be binomial. And again, a binomial would be either I rolled a 1 or I did not roll a 1. I don't have that here. I don't have binomial. So I'm already eliminating D and pretty much locking in on E. But let's see if we could figure out how to calculate these probabilities. So the probability of getting a 0 is that. Let's see if we can calculate that. So the probability of getting a 0 for my sum would be, I would have to roll a 0 the first time and a 0 the second roll. So this is the second roll. Second time I'm playing the game. And so, well, what's the probability? If they're 2 are independent, which they should be, you roll once, you're done with game 1, then you roll twice. Those are 2 independent events. If 2 events are independent, you should be able to multiply them. So when I get the sum of 0, it comes from rolling a 0 and then rolling a 0. So what's the probability of rolling a 0? And then I multiply that by the probability of rolling 0 again, because they're independent events. So the probability of rolling a 0 is 0.3. And it's still 0.3, and 0.3 times 0.3 is 0.09. So I'm feeling pretty good. But I can keep going. To roll a 1, to roll a 1, I either rolled a 1 the first game but a 0 the second, or I rolled a 0 the first and a 1 the second. So that's these two probabilities, and it can happen twice. So I'm going to have to add these two. I multiply these, but I add these two outcomes. There's two ways to get a 1. Okay, so the probability of getting 1 would either be getting a 0 and then a 1, or getting a 1 and then a 0. So the probability of getting a 0 would be 0.3, and the probability of getting a 1 is 0.4, or vice versa, 0.4 and 0.3. So as I multiply these two numbers, this would multiply to get 0.12, this would multiply to get 0.12, those would add up to 0.24. This is definitely my answer. Let me know if you need more guidance on that question. Now the next question states, the polling organization asks a random sample of 1,000 people, so N is 1,000. They registered the voters for 2 candidates, and their choices are candidate A, candidate B, or undecided. So it's kind of like Republican, Democrat, or independent. And here was the data they collected. It looks like all 1,000 people are accounted for. Now they're asking, George wanted to make a large sample of a confidence interval of 2 proportions to estimate the difference between these two, to create a difference of population proportion. This procedure is not appropriate. So right off the bat, the reason why it's not appropriate is you only did 1 survey. So that's just a given. You didn't take 2 samples, so you cannot do a 2 sample or a 2 proportion difference type of a thing. That's just not what we do. We can't do a difference thing. The sample size was too small. That's not the problem. That was not the problem. That's a huge sample size. The third category is invalid. That's not true at all. It's totally okay to have Republican, Democrat, and independent. It's okay to have an undecided. What's not okay is if these numbers don't add up to 1,000, and they do. So we've definitely eliminated. The sample proportions are different. That's just totally weird. I mean, again, if we thought this was Republican, I don't have to have the same proportion of people say Republican versus Democrat. I'm actually doing a survey because I think they might be different. So I have to choose A. The 2 sample proportion is not going to be allowable because they're not independent samples. We didn't take 2 samples, so we can't do, and we can't just break up the 1 sample we took because they might be dependent on one another, because this, again, is 1 sample. That is my summary of question 153 and 154. Thanks for joining us.